Whether you're gaming or working, running heavy things will turn your laptop into a space heater. Without good cooling, you'll lag and lose performance, unless you make this. Building off a janky prototype, we're going to 3D print a premium RGB cooling dock. To get that cyber gaming look, we'll try to get some multicolor LEDs to run some light algorithms, then we'll slap in a microcontroller and some other components to try to automate the temperature control. With complex electronics, thousands of lines of code, and a mandatory sleek design, we just gotta hope that it keeps my laptop cool and fast when we put it to the test. Like all my projects, it starts by firing up my printer with a slick design montage. After hours of work, this frame is looking sweet. I went through a thorough checklist and there's nothing else to change and it's perfect and ready to print. There's really nothing that could go wrong. I just gotta fire up my printer, bring this to my slice. Oh, it's too big for my printer. Okay, no, I'm just kidding. We'll split up the frame and then use threaded heat inserts to bolt it back together. Now that it fits, we'll send these parts off to my 3D printer and in the meantime, we'll figure out how to control these fans with a microcontroller. We can do that by using something called pulse width modulation, where the motor is on as long as the pulse is high. If it's high for 10% of the time, then the motor turns at 10% speed. The wider the pulse or duty cycle, the higher the average voltage and the faster the motor spins. That way, we can set the speed to anything between 0 and 100%, which gives us way more control than just an on or off switch, and it will allow us to autonomously adjust the fan speed if we add a special sensor. Okay, with that figured out, let's see how our printer's cooking. The splits in the frame are hidden well, because instead of designing this like a Minecraft house, I added in some zesty geometry. Okay, so somehow we gotta tell the microcontroller what we want the desired fan speed or temperature to be set to, and to do this, we'll take the same setup I used to build my camera slider in the last video, which is an OLED screen and rotary encoder. It's a simple way to control any settings, and it's pretty versatile, so I can add in more features like the RGB LEDs to control brightness or color sequence, which is what I'll need to do if I want to get that cyber gaming look. To do that, instead of just using regular strip lighting, where you can only change the LEDs to be the same color, we'll use addressable LEDs so we can change each pixel individually. Then we can design some animation algorithms to have any light sequence that we want, like the classic rainbow. We still gotta figure out how this knob is gonna select all these animations, and we gotta clean up the look of this bare LED strips. But that's a later issue. For now, we gotta deal with this janky breadboard. There's no way we're keeping the electrical this way. I don't want wires coming undone causing short circuits or fires, because that would be the exact opposite of what a cooling pad should do. So we'll solder robust connections on a perforated board, then we'll finally have everything we need for a crisp build montage. Oh, yeah, it's not going to turn on because we don't have any firmware, so we got to write that and upload it so we can control all these features. I did something pretty cool when writing the code to select the light animation. Instead of using a huge switch statement, I put the function pointers for each algorithm into an array, so when you turn the knob, you change the array index that gets run, which allows you to easily select the LED animation. Clicking the knob changes the page where you can adjust other settings like fan speed, but manually doing this will get repetitive and tedious. We could get the fans to automatically adjust to reach and maintain a temperature, but to do this, we'll need to make a controller and hook up a temperature sensor to provide feedback. Instead of adding more chaos to this rat nest of wires, why don't we go all in and design our own custom circuit board? Yeah, our started perf board's nice, but it's really just a bunch of off-the-shelf breakout boards that kind of work together. So let's take this project from a prototype to a premium design with our own custom PCB, where we can spec out the perfect components to build a powerful voltage boost converter, and for that we got to pull out this bad boy.
Each one I substitute the value of R. So for this one, V is 10.
But I can't make PCBs here in my workshop. Thankfully, PCBA has sponsored this project and provided the services to make it happen. Ordering is super easy because they source all the components for you. They're not just a PCB manufacturer, they can also do 3D printing, CNC machining, injection molding, and more. I tried out their 3D printing to print the entire frame in one go, and out of all the material options, I went with the matte black PLA, which looks great. With a wide variety of options, competitive pricing, and a quick turnaround time, PCBA is my go-to for all my project needs. Check them out with the link in the description to support the channel and to get a discount on your first order so that you can get a sweet looking PCB just like this. I asked you which color I should pick and you guys voted on purple. Great choice because it looks sweet. So let's cut out our old board, and instead of soldering wires, our PCB has connectors so we can crimp and plug in all the cables, including the one for our new temperature sensor. So now you can enable the PID controller and set a desired temp, and it'll get readings from the temperature sensor using I2C to automatically adjust the fan speed. It works great to maintain the temperature, and it even added in an animation to glow red to green to show what temperature it's reading. I'm really happy with how this cooling dock turned out. It pumps out a lot of air, and I actually used it while editing this video, and it really helped to speed up my computer. The auto fan controller and the glowing temperature indicator is a really nice touch that makes it super easy to use. The LEDs and the sleek fit and finish hides that it's a homemade project, and it fits in well with the rest of my workspace setup. If you want to make your own, in the description you'll find links to the print files, GitHub, and the PCB, along with the links to the parts and tools I use in this video. There's also a link to get a discount on your first PCBWay order so you can take your project to the next level. If you like 3D printed electronics projects, then you'll also enjoy my camera slider video where I used motors, gears, and pulleys to make some sick camera equipment. If you enjoyed this video, consider giving a thumbs up. Your like makes a significant difference, especially for a smaller channel like mine, so thank you for the support. I got more projects I can't wait to show you, but until then, you can subscribe here, or you can watch the video over here, or you can watch the video here and subscribe. It's going to be my first time doing that, so I'm not sure where it's going to be. You'll see, guys. Just one of them is going to be subscribe and then like, or whatever, watch the video. Whatever, I hope you do it. See you guys in the next one.